Welcome to today's video where we're going to learn how to convert from the volume of one gas at standard temperature and pressure to moles of another in a chemical reaction. Before we get too far into this, first thing I need to do is define what is STP. What does that mean? And this only works with an ideal gas. We'll define an ideal gas later, but for right now, we'll be concerned about STP, which stands for standard temperature and pressure. Standard temperature and pressure is a condition that chemists use to make their math a little bit easier. So if we're able to set things at standard temperature, which is 0 degrees Celsius, and pressure, which is 1 atm, we'll get into the explanation of what these pressure units are later, but to give you an idea of what 1 atm is, 1 atm is the atmospheric pressure, so the pressure of what the air that you feel around you at sea level. All right, and then 0 degrees Celsius is the freezing point of water. All right, so we are able to, chemists have determined that if we are working with an ideal gas, the space that the ideal gas will occupy, that 1 mole of the ideal gas will occupy, will always be the same, no matter what type of an ideal gas it is. Again, this requires several assumptions, however, it is good enough for us to use as calculations. Step 1 for converting from the volume of one gas at STP to moles of another is to write the balanced chemical equation. All right, so here's our sample problem. One method for preparing oxygen gas is through the decomposition of potassium chlorate. So sometimes if a chemist needs to produce oxygen gas, they will decompose potassium chlorate. How many moles of potassium chlorate must we decompose in order to obtain 2 liters of oxygen? Here's our equation. This is not balanced, so in order to balance that, we will write 2 KClO3, and that's a solid, to yield KCl, and we'll say that that is a solid. And then our O2, we'll have 2 of those, and then we'll have 3 O2s, and that is a gas. All right. Now that that's balanced, check. Step 2 is going to convert from volume of A to moles of A. Once we get to moles, we're able to cross the mole bridge and then go wherever we please. So, real quick, let me write this sentence down. 1 mole, so chemists have determined that 1 mole of an ideal gas at STP occupies a volume of 22.4 liters. All right. Using that sentence, that gives us our conversion ratio. So, step 2, if we're given 2 liters of oxygen, next our unit on the bottom right hand corner must be the exact same, so liters of O2, and we're going to convert to moles of O2. Now, from our conversion ratio right here, that means that 1 mole is going to occupy 22.4 liters. All right, let's plug that into our calculator. We get 2 times 1 divided by 22.4 gives us 0.089. And this is moles of O2. All right, once we've got moles of O2, now we're at the footsteps of the mole bridge, so we can traverse the mole bridge by converting from moles of A to moles of B. And again, this is our mole bridge. And in order to traverse that, we are going to use our coefficients. And like I said before, this is a fantastical bridge because once we cross the mole bridge, we can convert to whatever quantity we would like. So we'll take our 0.089 moles of O2. We have moles of O2 on the bottom right-hand corner, and we are looking for moles of potassium chlorate. All right, so we're going to take our 3 down here, our 2 up here. 0.089 times 2 divided by 3 gives us 0.0595. And these are moles of KClO3. All right, hopefully this is helpful because once we get to moles of KClO3 or potassium chlorate, we are able to convert to whatever quantity of potassium chlorate we would like. Then it's just following our steps from before. Hopefully this is beneficial. Enjoy.